What if the Earth was cut in half? Imagine, for a moment, looking up at the sky, not to see the gentle arc of the horizon or the endless blue vault, but to see the ragged edge of Earth itself, sliced clean down the middle. What would it be like if the Earth, our entire planet, was cut in half? To ponder this idea, set aside the vast unlikelihood of such a scenario ever coming to pass with current technologies or natural phenomena. Instead, let's unfold the fiction, guided by physics, geology, and imagination. Suppose, instantaneously and with complete impossibility, an immense cosmic force shears the Earth in half, right through its rotational axis, from the North Pole, through the center, to the South Pole. A perfect meridional division. What happens next is a cascade of cataclysms and transformations beyond any disaster humanity has ever conceived. The very first moment after the cut, everything seems still, as if time pauses in shock. The Earth, previously a globe kept whole by gravity's gentle but unyielding squeeze, is now two massive hemispheres. Each half, the western and the eastern, has much less mass than before. For a moment, the cut faces each other, with the planet's innards exposed. The outer crust and mantle, the semi-fluid outer core, and the dense, mysterious inner core at the very center, now visible for the first time since Earth's formation. Gravity, however, knows no such hesitation. The force that has always pointed everything down towards the planet's center now finds an unbalanced world. The cut halves immediately begin responding, tugged not only towards their own new centers of mass, but also by the gravitational pull of the other half, just kilometers away across the gaping void that was once Earth's core. The exposed inner layers, never meant to see sunlight or touch open air, erupt and collapse. The crust is the thinnest layer, barely 30 to 60 kilometers deep on land, thinner under the oceans. So the inner heat, previously insulated by miles of rock, has nothing holding it back. Freed from pressure, the outer core, composed of molten iron and nickel, kept liquid by immense heat and pressure, begins to cool and congeal. But not before fountains of molten metal and rock pour outwards, vaporizing into plumes of lava, magma, and rock dust. Mountains of the mantle crumble at the new edge, pushed and pulled by forces never intended to act on naked, fragile geology. As the halves pull away, gravity warps. At the planetary edges, the pull of mass is redirected inwards, towards the center of each half, dramatically altering how things fall, how rivers would flow, and even how buildings stand. Objects near the cut edges experience a dramatic drop in surface gravity because there is less mass beneath them. In the exposed region, the gradient is sharp. Stand too close to the edge, and you might start falling sideways into the void. Spaces that were once ocean floors or a deep continental crust are suddenly open. The deep blue of the Pacific or Indian Oceans falls away into canyons with no bottom. Oceans on the near side of each hemisphere surge and boil off into the abyss, their once contained waters vaporizing from the sudden exposure to the Earth's deep heat or tumbling away under altered gravity. Ripped from their ancient unity, the halves cannot remain side by side for long. Their mutual gravity tugs at each, but the conservation of angular momentum, Earth's spin, demands motion. If the cut happens instantly, shock waves like no earthquake ever felt ripple through what remains of the land. Seismic devastation that topples cities, mountains, and continents alike. The two halves begin to drift apart, spinning away from each other on their altered axes. Atmosphere, previously pressed to the surface and trapped by a complete planetary shell, behaves chaotically. Near the split, air rushes toward the new void, expanding and cooling rapidly, producing hurricane-force winds and shock fronts. Dust, ash, volcanic gases, and superheated steam burst into the sky from the gash, creating a hemisphere-wide storm that blots out the sun and rains fragments of molten rock. Meanwhile, the Moon, Earth's silent partner in orbit for more than 4 billion years, responds to the abrupt new gravitational configuration. With the mass of the planet halved and split, the Moon's orbit destabilizes. It might spiral closer, risking impact, or be flung away, possibly escaping into interplanetary space. Tides collapse, causing coastlines to flood or recede unpredictably. Nights grow wilder as the familiar lunar cycle is replaced by chaos. For humans and all life, the consequences are dire and immediate. Earth's stability, its cyclical seasons, day and night, the migrations of animals, tides, weather, even the planet's protective magnetic field, has vanished. The core, split, and bleeding energy can no longer sustain the dynamo effect that forms the magnetic field and shields the surface from the fierce solar winds. Over time, the radiation from the sun bombards the exposed surface, stripping away the atmosphere that shelter life from ultraviolet and cosmic rays, blowing it into space. Survival in this new world is impossible for most forms of life. Plants, animals, and humans near the cut perish instantly, overcome by seismic shocks, atmospheric collapse, and exposure to deadly volcanic material or the black pit of the void. Even those further afield face starvation, freezing temperatures, or suffocation as the planet's remaining atmosphere and water boil away or are lost to space. Yet, for the sake of imagining further, suppose that some people survive in protected environments, deep underground, or in heavily shielded cities built for catastrophe. On this halved Earth, they would find themselves in an alien world. Gravity is weaker, especially closer to the edge. The sky splits in one direction, with stars blindingly visible at the close horizon where Earth once continued. Standing at the rim, you would see the other hemisphere, if it remains close, a gigantic curved wall in the sky, perhaps glowing with fire and molten rock, perhaps slowly drifting away, or even slowly tumbling into the distance. Days and nights lose their old rhythm. If Earth's axis of spin is preserved, one half still experiences rotation, but with less mass and altered inertia, day lengths would change. The former 24-hour spinning cycle might be shortened or lengthened, erratic at first, gradually stabilizing as each hemisphere settles into its new mechanics. Earthquakes become a daily ordeal as the internal structure, never designed for exposure, twists and compacts under gravity in this new shape. The two hemispheres, their cut faces cooling slowly, might shed fragments, forming fields of asteroids or satellites that swirl between them. Friction and the uneven distribution of mass could eventually shatter each hemisphere further, breaking Earth not just in two, but into many smaller worlds. If any semblance of atmosphere remains for a time, weather patterns would be savage. All the mechanisms that drive wind and rain, temperature gradients, atmospheric pressure, the Coriolis effect, are thrown into chaos. Violent storms, unmoored from old boundaries, cross the fragmented surface. Rain may never fall again. Instead, the air might condense into clouds of acid-tinged vapor that drift ever lower, feeding strange new rivers into the abyss. Meanwhile, the sun shines on, indifferent to the drama of this small planet. With so much mass lost and no longer held in a compact spheroid, Earth's orbital path around the sun would be perturbed. The halves might spiral closer to the sun, burning up, or drift further away, freezing solid. But let us draw back from apocalypse and pause at that breathtaking first moment. Two hemispheres facing each other, their inner workings exposed, continents sheared in two. What would an observer see? From space, the sight would be staggering, a crescent shell where green, blue, and white once covered a smooth surface, now abruptly ending in a hemisphere carved open, glowing red and gold with the heat of the mantle and the white-hot flashes of the core cooling in the cold vacuum. Volcanoes erupt across the cut, rivers of magma spill into nothingness, and clouds of vapor and debris billow out into orbit. If it were possible to survive and travel to the cut rim, you might descend layer after layer of the Earth's structure, passing through the crust, broken and shattered, the harder, denser rocks of the mantle, the brittle transition zone where the rocks change form, and down at the very edge, the cyclopean glow of the core, a place hotter than the surface of the sun, now cooling and hardening into strange new metals never before seen by human eyes. Could anything survive in such a world? For multicellular life, almost certainly not. But extremophile bacteria, known to thrive near volcanic vents or deep within rocks, might cling to existence in the warm, nutrient-rich zones near the exposed core, feeding on chemicals and the dwindling heat. In millions of years, perhaps, new forms of life could adapt to this alien world, evolving in the shadows and cracks of the new hemispherical shells. If intelligent life ever emerged again, they would find a planet fundamentally altered. The view of the sky would be a daily lesson in the violence that shaped their world. Myths would grow around the mysterious edge at the world's end, where the air thins and sunlight falls into the bottomless void. Over the ages, the two halves, in their altered orbits, might collide and coalesce, drawn by gravity's inexorable embrace. The debris scattered between them could accrete, forming moonlets or new continents. The cycle of formation and destruction, so crucial in planetary science and the life cycles of celestial bodies, might, in the fullness of cosmic time, reshape the planet into a new form, smaller and rougher, yet spinning once more in the sun's light. To contemplate the halving of Earth is to recognize the immense fragility of our home, the intricate balances that sustain life, and the awesome forces at work within the planet's very heart. The scenario is as impossible as it is fascinating, a profound reminder that, despite the ground's apparent solidity, the world we know is but a delicate balance of rock, metal, water, and air. Such a fracture would unmake not just continents and seas, but the histories, cultures, and lives that have evolved across millennia. The unity of Earth, shaped by time and fate into a living world, would be lost in an instant. And yet, perhaps, in the ruins, the seeds of new worlds would one day arise, demonstrating, even in destruction, the ceaseless creativity of the cosmos. Thanks for sticking with us until the end of the video. What do you think would really happen if this became reality? How would the world change? Share your thoughts or your own what-if theories in the comments below. Who knows? Your idea might inspire our next video. If you found this interesting, don't forget to like, share, and subscribe to keep exploring the wildest possibilities with us. See you in the next unexpected What If adventure.